Hi guys, let's take a look at this question where learners investigated the relationship between the net force and acceleration by pulling a trolley across a surface which is slightly inclined to compensate for friction. The trolley is connected to different masses by a string of negligible mass, and the string passes over a frictionless pulley. And then they give you a nice diagram. Ticker tape is attached to the trolley passes through the ticker tape. The acceleration of the trolley is determined by analyzing the ticker tape. The results of the net force produced by the different masses and the acceleration of the trolley was recorded in this little table here. We have the net force and we have its acceleration at the different masses. 3.1. Write down a hypothesis for this experiment. So hypothesis for this experiment could be the net force is directly proportional to acceleration if the mass of the trolley is kept constant. Always remember to have your dependent and independent variable in that hypothesis. 3.2.1. Identify the independent variable. The independent variable is on the x-axis. The dependent is on the y-axis, and like I always say in a table, x is first column, y is second column. So the independent variable here is the net force because it's on the x-axis. Then the controlled variable will be the one that is constant, and that is the mass of the trolley. Okay, mass of trolley. 3.3. Use graph paper to draw this graph of acceleration versus net force. Okay. So let's draw this graph. Again, as with all my graphs, I'm trying so hard to draw a straight line. Wait. Almost straighter. That's better than what I've been doing so far. All right. You have to write a heading. So this is the graph of acceleration versus net force. Your acceleration will be on your y-axis. Please don't forget to write the unit of measure, meters per second squared. And then your force will be on your y-axis, Newton. All right. Then you just have to plot all these points on the graph. That's what I'm going to do right now. Okay, we have 0.3 and 0.36. So it's somewhere here and somewhere in the middle there. Then we have 0.6 and 0.73. So somewhere there. You'll have graph paper, so it will be easier. Next one, 0.9 and 1.09. Then we have 1.2 and 1.45. Oopsie. Let's just, okay. And then the last one is 1.2 and 1.45. I think I might have said that already. So somewhere there. And it should give you a straight line. Mine is obviously not a straight line because I'm not using graph paper. But please just draw a straight line through all the dots. And make sure they connect. 3.4. Calculate the gradient of this graph. So you can use any 2 points of the graph to calculate that gradient. So 3.4. So let's just use the first one and the last one for fun, right? So y2 minus y1 over x2 minus x1. So it'll be 1.45 minus 0.36 over 1.2 minus 0.3. And that should give you 1.21. And the gradient will obviously be the same in the whole graph. So you can choose any 2 points on the graph and chart it into the formula. And that's it, guys.